Hi, everyone, and welcome back to another Planetarium live stream. My name is Jessica. I am the director of the Planetarium, and with me tonight is one of our students who I will let introduce herself.
Hi, I'm Lindsay. I'm a physics graduate student at UMD.
So tonight we have the history of astronomy that Lindsay has been working on for a while. This has been a show that's been building, I would say, over at least a year. Um, and it explores a lot of the women who made significant contributions to the field of astronomy, but don't really get the credit for their work. And so we, of course, like to highlight that. So I'm going to hand it over to Lindsay. And if you do have any questions throughout the show tonight, feel free to leave them down in the comments. I will be watching out for those, and we'll let Lindsay know if a question pops up. We'll also have time at the end to answer questions too. So with that, take it away, Lindsay.
All right. Okay, so my goal for this show is to not spend too much time on any one woman who has made a significant contribution to astronomy, but just to introduce you to a bunch of names, because the more and more I kind of research this and learn about all of the women who participated in the science of astronomy, I keep learning about more women. So I keep adding them to the show. And I think it's important that all of them get their, names heard so that people know who they are. So we're going to start kind of back in ancient Greece, the 2nd century BC, with a woman named Aglionice. So this woman, she had such great knowledge of the patterns of the moon and the sun that she was able to tell when an eclipse, a lunar eclipse was going to happen, or a solar eclipse was going to happen, or when the moon was going to rise above the horizon. And because she was able to make these predictions so accurately, people actually thought she was a sorceress. So pretty cool that she was wielding her scientific knowledge to be a sorceress. All right, now jumping all the way up to the 4th century AD, Hypatia. She was a professor of ancient astronomy or of astronomy in ancient Greece. She also taught mathematics and astronomy at a local school. And in addition to teaching the students that went to that school, she would have public lectures, kind of like we have at the planetarium, to teach the public about math and astronomy as well, and do some outreach. Jumping all the way up to the 10th century, Mariam al-Astrolabi, she manufactured astrolabes. That's this tool over here. It's used to make measurements in the sky and kind of help you find things up in the sky. 16th century, we have quite a few. So first we're going to talk about Sophia Brahe. So you may have already heard of Tycho Brahe. Tycho Brahe was Sophia's brother. He was a pretty interesting person. He was the royal astronomer of Denmark at this particular time. He had a metal nose because he lost his nose dueling, so he's kind of known to be kind of a weird scientist. Anyway, she assisted her brother Tycho with astronomical observations, and they needed really accurate observations and data for the planet movements up in the sky, because the royals of Denmark, they needed that data to be accurate so that they could accurately predict astrology things. So back during this time, these astronomers were actually getting paid to do all of this data research so that they could have accurate astrological readings. They also discovered a supernova. In the 17th century, we have Maria Kunitz. She authored a book that included new solutions for determining the position of the planets. Elizabeth Hevelius, she was known as the mother of moon charts. And she and her husband, Johannes Hevelius, cataloged more than 1,500 stars. In the 18th century, we actually have quite a few women from France who were doing things with astronomy. This is Nicole Renée Lepoté. She was a French astronomer who predicted the return of Halley's Comet. Marie Jeanne Amélie de Frances de Lalande, she established a catalog of over 10,000 stars. Carolyn Herschel, this is another sister of a famous astronomer. She was the sister of William Herschel, and she helped her brother William discover Uranus. They also, actually, she discovered the comets. So anytime you see a comet that has the Herschel name, like Herschel and then a number, it's actually named after Carolyn Herschel, not William Herschel. She also created a new star map, and she was the first woman to actually get paid to do astronomy. Back in France, we have Princess Charlotte of Saxe-Meiningen. She participated in observations with the astronomers that were at the French court at the time, and she also attended the first European Astronomy Congress in 1798. Right. The 19th century, Emily du Châtelet, also from France, she translated Isaac Newton's famous book, the Principia, into French. Isaac Newton also made a few mistakes in his book, and so she corrected those when she published it and translated it into French. Maria Mitchell, she discovered a comet in 1847, and she won a gold medal prize from the King of Denmark for that. Agnes Mary Clerk, her greatest work was a book called The Popular History of Astronomy during the 19th century. Mary Adela Blagg, she observed the moon and she created a list of all of the lunar features that she could see. And she created a system for naming things on the moon. And we still use that system and we name things that we find on the moon like craters. Okay, so now we are to about the late 1800s, early 1900s. The Harvard Observatory at this time had a lot of female computers. So they are sometimes referred to as Pickering's Harem. So the head of the Harvard Observatory at the time was Edward Pickering. He hired a bunch of women to analyze the pictures from the telescopes at the Harvard Observatory. So he hired a bunch of women. They were cheaper than the men. The women, though, could not actually go and take their own pictures or look at the telescopes themselves. The men would get to look through the telescopes and take the pictures, and then the women would look at all the data and pictures and discover things from there. And even though they were only hired kind of as second-class citizens, as human computers, they actually made a lot of really important discoveries in their own right. So Antonia Maury, she published an early catalog of stellar spectra. Spectra is kind of like the color that we see coming from a star. Wilhelmina Fleming, she cataloged thousands of stars and helped create a classification system that we still use. She also discovered the Horsehead Nebula, which is this nebula right here. Henrietta Leavitt, she discovered Cepheid variable stars and that they could be measured or used to be measured distances. So the importance of this particular discovery actually ties into us figuring out how far away galaxies were. So before this, we didn't know if there were other galaxies outside the Milky Way galaxy. So when we looked up in the night sky and we saw these spiral objects, we weren't sure if those spiral objects were like, these nebula that we have in the Milky Way galaxy, or if they were spiral structures and their own entirely separate galaxies outside the Milky Way galaxy. We didn't have a way to measure to those spiral structures to see how far away they were and if they were far enough to be outside the Milky Way galaxy. So anyway, Henrietta Leavitt discovered a law that so she noticed that Cepheid variable stars always reach the same luminosity. And so since that happens, you can tell how far away a Cepheid variable star is by how bright it looks to you, because they all get the same brightness. So Cepheid variable stars that are farther away are going to be dimmer, and Cepheid variable stars that are going to be closer are going to be brighter. And so Edwin Hubble, somebody you may have heard about, he ended up using this law from Henrietta Leavitt to actually measure those spiral objects that we saw in the sky and discover they're not actually other spiral objects in the Milky Way galaxy, but they're actually entirely separate galaxies besides the Milky Way. So Edwin Hubble, next time you hear someone talk about him, would not have been able to make his discovery about galaxies without Henrietta Leavitt. So everybody should know who she is if they know who Edwin Hubble is. Annie Jump Cannon, she established the stellar classification system that we still use. Cecilia Payne, this is one of my other favorite women that I have learned about. She discovered the composition of the sun, no big deal. Before this time, actually, scientists thought that the sun was made up, had a similar composition to the solar system. So since the sun and all the planets and everything in our solar system formed out of the same gas cloud, that the sun would have the same composition as the rest of the solar system. But Cecilia Payne-Kapashkin, she actually found out that the sun is mostly made of hydrogen and helium, which was, again, completely not what they thought. And they actually thought that she was wrong for a while until a man was able to confirm that she actually was correct. Muriel Mussel-Seifert, she discovered the Ring Nebula, which is this lovely nebula right here. Okay, now we are into the 20th century.
I have a question, actually.
Yes.
Not from the chat, I just have one. I recognize the name. Is she also who Seaford galaxies are named after?
I think that is someone else. But that's something maybe I should look into. Maybe that's a relative of hers or something.
I might Google real quick while you move on.
Elizabeth Alexander. So during World War II, actually, she was working on radar technology. So she actually wasn't an astronomer to start out with. But she did help pioneer radio astronomy. So stars and other things out in space, they're emitting light. Well, a type of light is actually radio waves. So radio waves, X-rays, gamma rays, those are all different types of light. And so you can use radio waves, gamma rays, X-rays, and also visible light to observe things out in the universe. And so she used her knowledge of working with radar technology during World War II to help kind of create some instruments and things that could help us see radio waves in space. Ruby Payne Scott, she was an Australian pioneer in radio physics and was the first female radio astronomer. So she and Elizabeth Alexander both kind of started out as radio astronomers and were some of the first. Priscilla Fieldsbach, she authored papers on star clusters and star magnitudes. And she is over here with her husband, and he was an astronomer also. Ava Einart Rolfs, she made observations of variable stars. Elizabeth Roemer, she discovered 2 asteroids and also a moon of Jupiter called Themisto. She also collected data about the magnitude of comet nuclei, so how bright the nuclei or ball part of the comet can get. Erica Baum Vitens. She studied convection in stellar atmospheres. She also realized that UV light is the best way to observe the chromospheres of stars. So I just mentioned that radio waves and gamma rays, those are all different waves or different types of light that we can use to look at the universe. And so UV light is another type of light wave, obviously. And so she realized that looking at the sun with UV light instead of visible light or radio waves or X-rays or anything like that was the best way to see the chromosphere of the sun and other stars. Vera Rubin, she discovered dark matter. That is a very short sentence for an incredibly important discovery. So when we look at galaxies, the velocity of stars on the outside of galaxies are not what we think that they should be. So if you look at just kind of like basic mechanics based on the distribution of mass in the galaxy, so obviously there's more mass center of the galaxy, and then there should be less mass on the outside of the galaxy, and that contributes to the velocity of the stars in the outer part of the galaxy. Well, the stars we found in the outer part of galaxies are actually going a lot faster than they should be, given the mass that we see on the outside of galaxies. So the theory is that there is some type of matter that is making up that mass in the outer parts of galaxies that we can't see, that is kind of counting for that extra mass and why the stars out in the outer parts of the galaxy are moving faster than we think they should based on what we see. So dark matter is just matter we don't know how to see yet. Carolyn Schumacher, she once held the record for most comets discovered by an individual, not just women, but an individual. And that included comet Shoemaker-Levy 9, and that comet crashed into Jupiter's atmosphere. Rita F. Beebe, she was actually one of the people that helped study Jupiter when that comet hit the atmosphere. She is an expert on the atmospheres of the gas giant planets. Margaret Burbridge, she showed that all of the elements, except the very lightest, are produced by nuclear processes inside stars. So the main nuclear process that's happening inside the star is hydrogen fusing into helium, and then those are the 2 lightest elements. And then from there, creating carbon and iron and things like that, bigger or heavier and heavier elements. So obviously, you can't make hydrogen by fusing, because hydrogen is the smallest element. So hydrogen and helium were mostly created at the beginning of the universe during the Big Bang. So she found out that all of these other heavier elements were formed inside stars for the most part. Um, some um, some elements that are really heavy, like gold and things like that, actually formed during supernova explosions. Okay, she also helped develop an faint object spectrograph for the Hubble Space Telescope, and she helped discover that the galaxy M82 has a massive black hole at its center. Jocelyn Bell Burnell, she discovered the first radio pulsars using a radio telescope. Is right behind her. Nancy Roman, she was one of the first female executives at NASA. She also is known as the mother of Hubble because she helped plan the Hubble Space Telescope and was really involved in that. Steffi Baum also helped develop the Hubble Space Telescope. Maria Antonella Barrucci, she has discovered 3 minor planet discoveries. So minor planet is another name for like asteroids or Kuiper Belt objects. Tabitha Boyajian, she discovered something that's called Tabbys Star, which had a very unusual light curve. So there's a couple of different reasons why stars might have light curves. So light curve means that the light of the star is changing in brightness. So that might be a thing that is intrinsic to the star, just happening to the star happens to get brighter and dimmer. It can also happen if something is passing in front of the star, like another star, or maybe some planets. But with this particular star that was, varying in brightness, we didn't find any planets there. We didn't find any other stars that were passing in front of it. And so we don't really know why it is dimming and brightening. One idea that was thrown out there was that actually there are some aliens built some megastructures around this star. And so those megastructures are kind of blocking our view of the star occasionally. But I think since this discovery, that has since been debunked. But we don't have an idea about why that is happening still. And then Katie Bellman, this is about a year ago now, a little over a year ago. She created an algorithm for imaging black holes and led the team that finally was able to take an image of a black hole, which is this image right here. Jessica, did you find anything out about Seifert? Okay. That is so awesome that she was using her knowledge to like be super cool and be a sorceress. Mhm. Yes.
Muted. Sorry about that, guys. I didn't unmute myself. I know Lindsay could hear me, but I muted myself on the stream. Thank you, Susan, for letting me know that. So what I did say was to let us know in the comments if you have any questions for us. And also let us know your favorite woman astronomer that we've either discussed or maybe one we missed that you'd like us to include next time. And I was just saying that my favorite is the very first we talked about, the lunar sorceress. And yeah, she's definitely goals. I want to be a lunar sorceress.
If we could talk a little about why these women, like why we haven't really heard of many of them.
Yeah.
So mostly the men would, so mostly they were working for men or with men. And then the men would take their ideas and publish them as their own. There's also some, and this still happens, you may have noticed a lot of the women have hyphenated last names. So the reason why that is so like Cecilia Payne Kapashkin. Let's say she published some papers as Cecilia Payne with her maiden name before she got married. And then she gets married. If she uses her new married name, Cecilia Kapashkin, people might not realize that she's actually the same as the Cecilia Payne person that previously published earlier. So that is one struggle that female scientists have still to this day. Yeah, anything to
Yeah.
add, Jess?
No, I think that's pretty much. I mean, it's sad that all of this, the work they did was, I mean, like a lot of Pickering's. I mean, he published a lot of the women's work under his own name. Um, but this is part of why we like doing the show, is so that we can give them the credit that they deserve. Because they did some amazing stuff, especially some of the earlier ones. I mean, this was before computers, so they were doing like hand calculations, pen on paper, looking at pictures by eye and comparing and measuring things. Like, it's kind of crazy the amount of work that had to just. I don't know. I feel like I'm babbling at this point, but
How accurate they were. I mean,
yeah,
Henrietta Leavitt being able to figure out, her law just by looking at, glass plates taken
yeah,
by telescope.
it's crazy. So before we wrap it up for tonight, there are a couple of things that I want to remind everyone of. So we this weekend have our Stellar Distancing T-shirts for sale for $20. You can find the link to that in the video description. Excuse me, if you would like to purchase one. Proceeds are going to help us continue to do these live stream events, and they're also helping us prep for virtual field trips for schools this school year, since a lot of them do not have budgets for field trips this year. We still want to be able to participate, still be able to talk with the students in the classes and help out. So all proceeds are going towards those causes. Another thing we have coming up on the 26th is our socially distanced Stellar Saturday, where we're going to be out in the parking lot at the Planetarium from 1 to 3 on the 26th. And we're going to be passing out little mini activity kits, all focused around our moon. And so you can come by and pick up some really cool stuff. We'll have more detail coming out next week as far as specific types of activities and things. But you'll be able to pick up your own kit there. And then that night, we are doing a telescope stream because it is International Observe the Moon Night, which is why Stellar Saturday is going to be all about the moon. So we're really excited for this coming up, our first kind of in-person event since we've had to close back in March. Cannot believe how long it's been. We are going to have lots of safety precautions in place. We'll try and be as careful as we can, and hopefully this will go well. So we hope that you would stop by and see us and pick up some fun stuff.
We'll also have an option if you don't want to get out of your car, if you don't feel safe doing that, you can just drive up and we'll hand off some of the activities that we're doing in person.
Absolutely. And we'll have all of the details coming out right before, as far as where we're going to be, kind of the direction to kind of walk through, because we're going to have it, one direction to just keep everyone spaced out and safe, and then where the pickup will be if you just want to pick it up in your car. So we're excited. We've got a lot of fun stuff planned, and hopefully you will come out and see us and join us and enjoy it too. Other than that, next week, our shows for Wednesday are going to be all about aliens, what it would take for maybe life to develop somewhere else and some possible places that we are looking. And then on Saturday, Lindsay and Eli are going to be doing the scale and wonders of the universe and really show kind of how big it truly is and some of the really cool things that exist in our universe. So with that, I think we're going to wrap it up for the night. Thank you everyone for joining us. We hope you enjoyed the show and we hope you have a wonderful rest of your weekend and we will see you next time. Bye everyone.